Why are cells so small? Why do you have to use a microscope to see them? Why can't they be megacells? Why can't they be life size? Why are they so small? And you might think this question is completely unrelated to this topic on movement on substances. But actually, there is a link. For the answer to why cells are so small lies somewhere with movement of substances. And it also has something to do with surface area to volume ratio, which we're going to be talking about a lot more in this lesson. So in your textbooks, the information can be found on page 43 to 45. So why don't we have mega cells? Like these very cute soft toys. This red blood cell, I like it. It's so big and so fluffy and so cute. Why are all cells so microscopic? Well, the simple answer is cell size is limited by surface area to volume ratio. Cell size is limited by surface area to volume ratio. But what in the world does that mean? Well, let's get to the explanation. Now imagine for a moment that a cell is in the shape of a cube, like this cell here, which is 1 cm by 1 cm. I know they don't come in such big sizes, but just imagine for a moment. What if I asked you to estimate how much living material, how much cytoplasm is there in this cell that needs to be kept alive? How would you do it? Well, one way to do it would be to calculate the cell's volume. And the volume tells you how much cytoplasm there is in the cell and how much stuff needs to be kept alive. Now, in order to keep something alive, you will need to exchange substances with the environment. What do I mean? Now, for the cell to keep itself alive, it needs to take in nutrients and helpful substances, and it needs to give out waste and harmful substances. Now, if I asked you to estimate how fast and what rate, how fast can the cell exchange substances with the environment? How would you estimate this? Well, one way to do it would be to calculate the surface area of the cell. You see, if I calculated the surface area, so you take 1 times 1, this area, times 6 faces of the cube. Now, the surface area tells me how much surface there is that the cell can exchange substances across. So the greater the surface area, the faster the cell can exchange substances with the environment. Now finally, we ask the question, how can the cell survive? So given its volume, right, given the amount of stuff inside, given how fast it can exchange substance with the environment, can the cell survive? And for this, we look at the surface area to volume ratio. The surface area tells us how fast can I exchange substances to stay alive, and the volume tells us how much stuff there is to keep alive. The relationship with these two tells us whether the cell can survive. Alright, let's put some of that into practice. So here I have 3 cells, 1 cm long, 2 cm long, 4 cm long, and I want you to try to work out what the volume, surface area, and surface area to volume ratio is for each of the cells. And take a look at what pattern you find. So pause the video here and work it out for yourself. Alright, great job. Well, you should have calculated the following values. So just check your work. Just to let you know, for surface area, how you get it is like for this cell, 1 times 1, you calculate the area of 1 face, and you multiply by 6 faces. Okay, what do you notice? Did you notice that the volume increases by 64 times here? Okay, but the surface area only increases by 16 times. So volume increases at a faster rate than surface area as the cell increases in size. And the result is that the surface area to volume ratio decreases as the cell size increases. So you can see that here, for the smaller cell, the surface area to volume ratio is 6, and as it gets very big, the surface area to volume ratio drops. Now what that means is that as cells get bigger, they are less able to absorb nutrients at a rate that is high enough to meet their own needs. As cells get bigger, the amount of cytoplasm increases very quickly, but their surface area cannot keep pace, cannot increase as much. So the cell becomes less able to keep itself alive. And that is the reason why we do not have very big cells, because very big cells are so big, but they cannot absorb enough nutrients at a high enough rate to keep themselves alive. And so that is what it means by cell size is limited by surface area to volume ratio. So a related question is, why are large organisms made up of many cells instead of one large cell? And to answer that question, I want you to look at this scenario here. Alright, I want you to again do the same thing. Compare one big cell to 27 small cells, which are the same volume but it's divided into small cells. Okay, so compare these two and look at the surface area to volume ratio again. Try it. Alright, so if you've calculated, you should have gotten these values. Check yourself, check your work. Okay, this one here is because it's 27 small cells and each one has 6 cm square of surface area. So total is 162. Right, so what do you notice? First thing, volume is exactly the same, but the big cell is a smaller surface area compared to the 27 small cells. And therefore, having many small cells helps keep the surface area to volume ratio higher. See here, for the one big cell, the surface area to volume ratio is half. But having many small cells keeps it at 6. So this helps the large organism to stay alive because it still has a high enough surface area volume ratio to absorb nutrients at a high enough rate to stay alive. This big cell is not able to do that. It will not be able to survive. So that is why larger organisms are organized to many smaller cells rather than one big cell. Finally, for our last and probably most important question, we're going to ask ourselves, why do root hair cells and red blood cells have their particular shape? So why do root hair cells have these long and narrow protrusions, and why do red blood cells have these flattened shapes? To answer that question, take a look at these two cells. One is a cube and one is long and narrow. Again, I want you to calculate the volume, surface area, and surface area to volume ratio and see what you find. Now pause here and try. Alright, great job. Now what you should have gotten are these values. So check your answers. And to get the one for the long and narrow rectangle, you just have to calculate 4 of these rectangular faces, which is 27, and 2 of the square faces at each end. So you add up, it gets about 110. And do you see the pattern? So the volume is exactly the same, but the surface area to volume ratio of this long narrow cell is much higher. So we can say that for a given volume, in this case 27, the structure that is long and narrow has a larger surface area to volume ratio, and it can absorb substances at a higher rate. So that is why cells that are specialized for absorbing substances, like your root hair cell, especially the root hair, and your red blood cells, are usually modified to increase their surface area to volume ratio. So they tend to be long and narrow, like this long and narrow root hair. And for red blood cells, they have the biconcave shape. Both of this to increase their surface area to volume ratio so that they can absorb substances at a higher rate. So I hope that this simple video on doing the math and looking at different examples has helped you to appreciate a bit more about surface area to volume ratio and how it affects cells. Why are cells so small? Why are we made of many small cells? And why these particular cells have such interesting modifications. Alright, thanks. And well done for completing this chapter.